everyone, welcome to Aphelion the Mysterious Point. Today we'll discuss about the properties of Poisson's bracket. In the previous video we had discussed about Poisson's bracket. Now first of all we define Poisson's bracket. If we have two functions f and g, then their Poisson's bracket is given by fg in square bracket is equal to summation over k is equal to 1 to n dou f by dou qk multiplied by dou g by dou pk minus dou f by dou pk multiplied by dou g by dou qk, where pk and qk are our generalized coordinate and f and g are functions of these generalized coordinate and generalized momentum, as well as sometime function of time. These f and g are function of generalized coordinate qk, pk generalized momentum, and sometime also function of time. Now we are coming to the properties of Poisson's bracket. First of all, we will see its antisymmetric property. If we say the Poisson's bracket of f and g, then it will be equal to minus of Poisson's bracket of g and f. We can simply prove this expression with the help of this formula. If we replace g by f and f by g, then this relation will become g. This relation will we can easily verify using this relation. This property we can easily verify. After this we have next property. We will see some properties. Fundamental Poisson's bracket. We will see some fundamental Poisson's bracket, in which first fundamental Poisson bracket we see the fundamental the Poisson's bracket of two coordinates. Suppose we have n generalized coordinate q1 q2 dot 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 up to qn. Similarly, likewise we have n values of momentum. Suppose our point in space is defined by these coordinates, then Poisson's bracket of any two coordinates, means q1 q2 or q1 q3 or q1 q4 or q2 q3, any combination of coordinates, we will take q, k and ql. Then we get, suppose we have q1 and q2, we are calculating the Poisson bracket of these two coordinates, we will get 0, as well as the Poisson bracket of a coordinate with itself is equal to 0. Similarly, if we take Poisson bracket for two pair of momentum, then we get, suppose p1 and p2, we get 0. Similarly, p1 and p1, if we take the Poisson bracket of same momentum coordinate, then again we get 0. So we have these two equations, fundamental, we also call them as fundamental Poisson's bracket. One more fundamental Poisson's bracket we can see, the Poisson bracket of generalized coordinate and generalized momentum, where k are from 1 to n and l is also from 1 to n. This is equal to delta kl. Delta kl means if k is equal to l, then we get this value 1. If k not is equal to l, we get 0. If k is equal to l, we will get Poisson bracket of qk and pl is equal to 1. And if k not is equal to l, then we get 0. Suppose we are taking some examples. Suppose we have k is equal to l is equal to 1. Then q1, we have k value 1, l value 1. Then we can write this expression q1 p1. This will give us 1, because k is equal to l is equal to 1. Suppose we have k is equal to 1 and l is equal to 2. Then we can write this expression as q1 p2, l is equal to 2, q1 p2. Then we get Poisson's bracket of q1 and p2 is equal to 0. So, which is showing in this equation, as this is we are getting the Poisson bracket of generalized momentum and generalized coordinate is a delta function. When k is equal to l, then we get 1, and k not is equal to l, when we get 0. Sorry, k not is equal to l. So these three equations denotes our fundamental Poisson's bracket. Now moving to the next property, which states that Poisson bracket of a function with itself is 0. Means if I am taking the Poisson bracket of one function with itself, then we get 0. Suppose we have function f, then if I will take the Poisson bracket of function f with itself, function f with f, we get 0. We can substitute here g is equal to f, then this term and this term will be same, then these two terms cancel out and we get 0. Next, Poisson bracket of a function with any constant, Poisson bracket of a function with any constant is 0. Means Poisson bracket of a function with any constant c, suppose we have c is a constant, then Poisson bracket of any function f with c is equal to 0. We can prove this by substituting g is equal to c. If we substitute g is equal to c, g is equal to c, g is equal to c, then this differentiation, this partial derivative will be 0. This partial derivative again become 0. This 0, 0 minus 0 means 0. We can verify easily this property. Now, moving to some important identities of Poisson's bracket, means how we can apply if we have combination of functions. We will see some examples. Here we have Poisson bracket of c multiplied by f and g, c into f with g. Poisson bracket of c multiplied by f with g, where c is constant, f and g are functions. If c is constant, then we can write this as this expression. We can place c outside this Poisson bracket and Poisson bracket of f and g. This is our first identity. Then second identity is this. If we have to calculate the Poisson bracket of sum of two functions with other function k, f plus g with k, we get Poisson bracket of f and k plus Poisson bracket of g and k. Moving to the third property, third identity, we have f comma g multiplied by k. We have Poisson bracket of f comma g multiplied by k. We can write this as Poisson bracket of f and g multiplied by k plus g multiplied by Poisson bracket of f and k. So these three identities are very important for solving any questions, which we'll see in other lectures. Now, coming to the most important point here, we noted that point. This point is, if a function whose Poisson bracket with Hamiltonian is 0, if we have a function whose Poisson bracket with Hamiltonian is 0, then that function will be constant of motion. Means if f is our function, then if f Poisson bracket with Hamiltonian is 0, means Poisson bracket of any function and Hamiltonian is 0, then our function is constant of motion. So this note is very important, so try to grasp this note. And these all properties are also important for your examination as well as for your competitive exam point of view. So please go through these properties and this note. So this is for today's topic, properties of Poisson's bracket. I hope you all like it. And for more videos, like, share and subscribe, and be with Aphelion the Mysterious Point for more videos like this. Thank you very much.